In this video, I'm going to show you how to do AQA A-Level Maths, Paper 1, June 2018, Question 5. My name is Sunil Tanna. I'm a tutor and author. Details on the card. I'm available for one-to-one tuition, both online and in person. I live in Buckinghamshire in England. Okay, Question 5. A curve is defined by these parametric equations. X is equal to 4 times 2 to the power minus t plus 3, and y is equal to 3 times 2 to the power positive t minus find, and show dy dx is equal to minus 3/4 times 2 to the 2t. Okay, so what we need to do first of all is find dx dt and dy dt. So dx dt, differentiating the first equation, will be 4 times, when we have 2 to the power of minus t, the derivative of that is natural log 2. Because there's a minus sign, we'll have a minus in front of it as well, times 2 to the minus t. Right? So that means that dt dx is 1 over that, so it will be 1 over minus 4 times natural log of 2 times 2 to the minus t. Similarly, we find dy dx by by differentiating y with respect to t. This will be 3 times natural log of 2 to the t, and dy dx is dy dt times dt over dx. The two dt's will cancel out like that. So we will have 3 times natural log of 2 times 2 to the t divided by, I should probably put a time sign in if you like there, minus 4 times natural log of 2 times 2 to the minus t. Now the natural logs of 2 on the top and bottom of this fraction will cancel out, which leaves us as the constants is 3 and minus 4, so minus 3/4, and then 2 to the t divided by 2 to the minus t. When you're dividing, you subtract indices, so it's t minus minus t, or times 2 to the 2t. So it's minus 3/4 times 2 to the 2t, which is what we wanted. Find the Cartesian equation of the curve in the form of xy plus ax plus by equals c, where a, b and c are integers. Okay, so what we need to do to find a Cartesian equation is eliminate the variable t. Now the way to do this is to look at the equations and see if we can substitute one into the other. Now you'll both notice they both contain a variant of 2 to the t, obviously 2 to the minus t in the case of the x equation. So what I will do is first of all rewrite the x formula. To avoid the minuses, to make it a little bit easier, I'll think of it as x is equal to 4 times 2 to the minus t is the same as 4 divided by 2 to the t plus 3. So if I rearrange that to make 2 to the c the subject, subtract 3 from both sides will be x minus 3, and is equal to 4 over 2 to the t. And now if I multiply by 2 to the t and divide by x minus 3, I would get 2 to the t is 4 divided by x minus 3. Now what I can do is substitute that into the y equation. So y is equal to 3 times 2 to the t, but I know 2 to the t is the same as 4 divided by x minus 3. And then I also have to put in the minus 5, of course. Now it just simply becomes a question of simplifying the equation and rearranging it to look like the original equation. So first of all, the top of this first multiplication will become a y is equal to 12 over x minus 3. I still have the minus 5 there. Okay. And now what I would do is multiply both sides by, well, first of all, add 5 to both sides. So y plus 5 is equal to 12 over x minus 3. Then multiply by x minus 3 both sides. So that will give me y plus 5 times x minus 3 is equal to 12. I can then expand out these brackets, which will give me xy. Then I'll do the x's first. 5x minus 3y minus 15 is equal to 12. And then if I add 15 to both sides, xy plus 5x minus 3y is equal to 27. And that's my final answer.